Another example of use in proportions helps us identify how many items or objects are in a population of something. You ever wonder how somebody can say that there's this many deer, in a certain area? Do they go out and count every single one of them? Well, one way that they can determine this is they can do some sampling. So say, for example, that we went out behind town one night and we counted and tagged 165 or 135 deer. So I know 135 of them are tagged. A couple weeks afterwards, I go out there, I sit down with my spotlight, and I'm looking at, and I see 140 deer. And out of those 140, 30 of them are tagged. And we can do that. We can count deer, 140. We observe that 30 of them are tagged. So in that micro sample, 30 of the 140 are tagged. Well, we assume that sample holds true for the entire population. So I'm starting to get the idea that I have a proportion here. I have 140 in this small population, and 30 of them are tagged. Well, in the larger population, I tagged 135 because I know I tagged those, but I don't know what the larger population is. So I'm going to describe that as X. So now I'm starting to have enough information to build a little bit of a proportion. So let's say, for example, that I take 135 tagged over the entire population. Entire population tagged versus entire population, and that equals my micro, which was I had 30 tagged within a micro population of 140. Tagged to population equals tagged to population. And assuming that the sample holds true, since I'm taking this information at the same area, I think I can solve this for my variable X. And again, with proportions, one thing that's kind of cool is there's a lot of cross multiplication that you can do. I can take any item on one corner and move it to the other corner through my process of algebra. It looks like a little magic, some shortcut, but I can take 140, remove it from here, and multiply it up there. So I have 140 times 135. What I might also do at the same time is I'm going to move this X to its opposite corner, and at the same time take this 30 and move it to its opposite corner. Again, I wasn't doing anything weird, we're just using some algebra. Basically, whatever I multiply or divide to one side, I have to do to the other. And with proportions, it just looks like I'm swapping things out from one corner to the other corner. Well, I kind of am, but I'm doing it with some very solid mathematical evidences. So 140 times 135 divided by 30, let's see, that's about 18,900 divided by 30 equals X. Divide those guys out, and so that equals 3 goes in 18,6, 3 goes into 9, 3, 0 equals X. So I found out what X equals. X equals 630. But what did that represent? Well, my original problem, that represented my belief of the entire population of deer that were around. So I can say that our county or our sample area has 630 deer, even though I only caught and looked at 140 of them. And that's how we kind of get an idea of how big a population is when we just take a sample. And all that's done through using some algebra and some proportions. I hope that's useful.